Yeah, so as Rosalind said, I'm the GM for site engineering at Relic, and all that really means is I'm responsible for the technical, all that really means is just the technical strategy and architectural direction for our internal platforms. New Relic, as many of you probably know, is an observability platform. And those of you that don't know, what that means is that we are a SaaS that absorbs the outputs of observable systems, so metrics, traces, logs, events, you name it, and we allow you to do interesting things with it, alerting, dashboarding. We're doing more and more AI functionality, and we're just helping make sense of all the data produced by your systems. And currently we're ingesting 1.3 billion events per minute, which is quite a lot. I think it's like 22 million per second. So we manage quite a large infrastructure. And rather than giving you even more boring biographical information about myself, I think it's more interesting to look at kind of where my CI/CD journey began and see how that's how things have evolved, but also how the themes have stayed consistent over the years with the themes that Isaac talked about in his talk. So when I went to look for screenshots for the Flickr deploy system, I was actually really excited to see that the talk that Flickr engineers gave literally 10 years ago about doing 10 plus deploys per day of our, at the time, PHP monolith. That talk is still up on SlideShare. The URL is really long, but it's much easier to find it by just Googling. And so if you want to go check that out, I think it's just kind of interesting to walk down memory lane. So in 2009, things looked like this. This is how we deployed the monolith. Flickr, by the way, was only ever about 12 to 15 engineers during this era. And so a lot of the tooling was homegrown and pretty simple, but it got the job done. And so if you look at what's at the top is something familiar, right? It's just a log of what's been deployed and when, but also there is a chat box. And you might say, why would you need to chat in your deploy log? And you need to chat in your deploy log so that you could tell people not to deploy it. The way the system worked is things went from, we called it trunk at the time, to staging automatically. And then you went and looked and saw if anything was broken on staging. And if it was, you went and said, whoa, no deploy please, because if someone deployed, those problems would be copied from staging to production. And I don't know, I just think it's really interesting to watch the progression of these UIs over time. So fast forward 10 years, I'm at New Relic now, and we're still deploying all the things, but all the things look very different. New Relic is just over 500 engineers, and until very recently, we literally had more services than we had engineers, right? So microservice architecture has introduced a lot of advantages, but also a lot of complexity into your tooling. And so we give our engineers a lot of freedom to do what they need to do to solve their problems. There's not a lot of restriction going on what language and platform you use. It's not a total free-for-all. You have to kind of make a case for it. But in the end, we end up with a pretty, it's not a PHP monolith. It's 500 services in as many as 8 different platforms. Fortunately, it's all in containers, which makes life a little bit easier in terms of operating this system and in terms of building tools for it. But there's still, the tools really have to nail it, right? Because otherwise, it's just impossible to manage all that complexity. So in 2016, we rolled out a Mesos Marathon-based platform to support our application and service developers, right? Folks that own most of the services that are stateless, that are either HTTP or network services, or they're queue consumers. So to serve that audience, we introduced Mesos Marathon, and it worked really well, honestly. It's still up. It's still most of those services still run on that platform, and everyone that's moved on to it has been super happy. However, as we looked at what if the application is a homegrown multi-tier distributed database, right? Which is what powers the core of New Relic's analytics features. It's called NRDB. If that's the case, deploying traditional deploy strategies just aren't sufficient, right? It's just too complex. There's too much state, right? You have to manage storage. If you're trying to grow the cluster, you have to move data. If you're trying to do maintenance, you have to make sure that data can be served from somewhere else. And we just could not handle that complexity using Mesos without just too much fragility. In the meantime, to serve the customers that we did get onto this platform, we introduced an abstraction layer called Grand Central. And Grand Central, the main feature of it is that it allows the service owner to declare what their service is and what it's supposed to do and how it needs to be deployed declaratively, and it's attached to their Git repo, right? It's in version control. And so you register your repo, the tool reads your description. The description looks about like this. Don't try to read it, it's just boring YAML like any other boring YAML. But it tells the system what it needs to know about deploying this service. When you feed that in, what you get back is this screen, right? Which, again, has all the same things on it, but obviously people have invested a lot more effort into making it look nice than the screen that we worked on at Flickr. But it's got all the same stuff, who deployed what when, what deploys failed, and what changes were deployed. But it's also a lot more complex because, again, we're now looking at a deploy page for one of the 500 services that we have, right? So the tool handles all our environments, all our different services. It's honestly pretty advanced, but it was built with Marathon in mind. So when it came time to serve the other 20 plus teams that were still just rolling their software directly onto hosts, right, and just interacting directly with hosts, whether it's through scripts or something like Ansible, we realized we had work to do. And so that's when the what I call the 2020 plus internal platform comes in. Actually, it's already in production, but we're still rolling it out. It's a multi-cluster Kubernetes platform where we're splitting things up both by functionality and also by customer cohorts to give us more reliability, more ability to experiment, and just being able to, and the Kubernetes bit is what enables us to actually serve the more complex use cases. So instead of just saying, hey, let's migrate all these happy application and service developers off of Marathon into Kubernetes, we said, who cares? They're already happy. We could literally make it so that they would click deploy one day and it would end up in a different orchestrator. They would not care. Let's target the folks we're currently not serving at all. And so we did that, and where possible, we're using stateful sets for our really complex use cases, like the aforementioned NRDB, which is, kind of looks like Hadoop if you zoom out far enough, but isn't really. We're using CRDs and operators. And for those for whom this is the first Kubernetes-related event, and you maybe don't know what that is, a CRD is a custom resource definition. It's just a way to teach Kubernetes about a new noun. And I say just, it's actually incredibly powerful. What that allows you to do is it allows you to write code that runs on the Kubernetes control plane that understands, new YAML that you passed to Kubernetes that it previously would have errored out on, and act on it, right? So you can say, oh, well, I have this NRDB cluster, Kubernetes knows what that is, and you can grow it, Kubernetes knows what that means. That's really, really powerful. But you need to deploy all that, right? So deploys look very different in this world. It's not just, oh, deploy the new version and make sure it works correctly. It's potentially deploy, new version to part of this particular tier of this complex system. It's potentially, run the data preload for this particular host before we deploy machines on it, right? Before we deploy code on it. So we have to support all that. We still want visibility into what's happening there. We still want the same features like audit logs and apples and all that. So Spinnaker, fortunately, has all those, right? So rather than try to build all of that into our own system, we said, let's embrace the community. Let's go where the rest of the Kubernetes community is already going. Let's take advantage of that. The highlight for us is Canary support for NRQL. NRQL is the language that you use to speak to NRDB. It's what we use to get metrics out of it. And you can tell Spinnaker a query, right? You can make it ask NRDB whatever you want. It's not just based on error rate or anything specific. Whatever events or metrics your service produces, you can interrogate those. And the community has delivered, right? We've really experienced that. We've been able to merge pull requests really quickly to adapt Spinnaker to our environment. The onboarding has been great. And now in 2019, boring, right? Just another Spinnaker screen, but here we are, right? Here's a bunch of production services deployed using Kubernetes. Using Spinnaker Kubernetes. We still have work to do. We would like to make Spinnaker understand what CRDs are doing a little bit better. And we still have to develop new patterns for new use cases, right? Those deploys look very different. We don't want every single team on the stateful service defining their own pipelines from scratch over and over. And when they do, we want to give them guardrails, right? We're still very early in this process, and we're still trying to figure out exactly how to get users to be able to do experimentation, but do so safely, still do canaries, still do proper validation, etc. I'm super interested in this topic. Obviously, like everybody else on the planet, we're hiring. So please come talk to me if you'd like. Here's my email address and LinkedIn. And thank you very much.